Hello, a very good morning to all, and welcome to my class. Today we are going to discuss biomolecules and polymer. So, previous chapter, we are also discussing this chapter with the PYQ and try to understand the whole chapter with some important PYQ questions. And I'm trying to give you the concept behind the question as well, right? So, today, basically, what we are doing now, today we are taking some PYQ questions of biomolecules and polymer. And related to this, I'll also give you a what type of question may be asked in your upcoming examination. So I'm going to discuss that also, right? So let's start with the today's session, that is biomolecules and polymer. And yeah, and beta, if you have any doubt related to any questions or any any solution, any problem, so please ask me in the chat box. I'm replying each and every queries of you, right? So let's start with the first question, that is this. This question is basically come in first this last JE paper. Okay, so what the question asks, beta, uracil is present, uracil is a base present in RNA. We all know that that is in DNA and RNA. Which bases is present, beta? We know that in DNA the base present is AGCT, and in RNA the base present is AGCU. So in this, uracil is present in RNA, where in DNA there is the absence of uracil base. Similar, thionine is present in DNA, where the absence of thionine in RNA, right? So this, please try to remember this: AGCT and AGCU. So AGCT in DNA and AGCU in RNA. So we know that uracil is a base present in RNA with the following structure. Now you have to calculate the percentage of N in the uracil. So how will you calculate beta percentage of N? For example, whenever if you want to calculate the percentage of anything, so what we know that if you want to calculate percentage, then mass or molar mass of the particular substance divided by the total mass into 100. So by doing this, we'll calculate the percentage of any any compound, any element in a compound. Okay, here also molar mass of nitrogen is given, oxygen is given, carbon is given, and hydrogen is also given. So we can calculate the molar mass of the particular nitrogen and the total mass, total molecular mass of this compound. And by dividing this two and multiply with 100, we can easily get the uh, that is the percentage of nitrogen. Let's see the solution behind this. We know that the molecular mass of this, yeah, this one, that is the structure, that is uracil. This is known as uracil beta, right? Uracil. So we know that the molecular weight of uracil is 112. How it come, beta? That is, we know that carbon having 12. So just multiply 12 into 4, right? Plus N2 having 14, 14 into 2, plus 1 into 4, plus 16 into 2. So bus, just calculate this, I will get 112 total molar mass. Now, what is the percentage of N here? The percentage of N beta, that is 28 upon 112, right? Multiply by 100. So what will get beta? That is 25%. So 25% is the correct answer for this question. I hope is it clear to everyone? That is 25 is the correct answer for this question. Yeah. Okay. So this is absolutely correct answer for this question. Now, the total number of tripeptide possible by mixing of valine and proline. So, this question is basically from the protein, that is a peptide bond. So total number of tripeptide. So in this question, they are asking total number of tripeptide possible by mixing of valine and proline. So let's see the solution. When you mix valine and proline, then how many, or we say total number of tripeptide possible. So we know that the one possibility is like now, that is valine, valine, and valine. So this is one possibility. We can calculate by using one simple formula as well. That is the number of possible tripeptide valine and proline is equal to 2 raised to the power 3. So it comes out to be 8 also. So you can calculate like as well. And here I also explain how 8 come, right? So one possibility is like valine, valine, and valine. The other possibility is valine, proline, and proline. Other is valine, valine, and proline. And similar, just reverse, proline, proline, and valine. So total out of this, total how many possibilities are there, beta? 8 possibilities are there. So number of tripeptide. Why we multiply 2 with 3? because here number of bond is tripeptide. So just multiply 2 by 3. And between two proteins only, na, that's why 2 multiplying 3. 2 raised to the power 3. So we can get 8 as a correct answer, right? So I hope is it clear to you? No issue in this? Right. Now, the next question is following tetrapeptide can be represented as. Okay, so these are the following tetrapeptide and this can be represented as. The code here like F, L, D, Y, I, Q, and P are the one letter code of the amino acid, right? So they are the one letter code of the amino acid. So following tetrapeptide can be represented as. कैसे represent होगा बेटा जल्दी फटाफट. So F, L, D, Y, I, Q, P one letter codes are given and you have to identify the tetrapeptide. So these are the tetrapeptide. Okay, it means they having 3 amide group, right? Okay, so tetrapeptide means 4 amide group. So sorry. So let's see the solution behind this. So we know that the hydrolysis of the given tetrapeptide will give the following. Like when we do this, then this is known as phenylalanine. L is known as leucine. D is known as aspartic acid, and Y is known as tyrosine. So which one is which of the options correct, beta? That is FLDY. FLDY, right? FLDY. So this is the absolutely correct answer. That is FLDY. That is option number 2, right? Now, let's move to the next question. That is in this question given below are the two statements. One is labeled as assertion and the other is labeled as reason. So what the assertion state beta? That is ketos give Selwyn's test faster than aldose. So ketos give Selwyn's test faster than aldose. And what is the reason behind this is beta? That is ketos undergo beta elimination followed by the formation of fuel, right? So the ketos undergo beta elimination reaction followed by the formation of furfural. So in the light of the above statement, you have to choose the correct answer, right? You have to choose the correct one. That is both A is false and R is true. Both A and R are true and R is the correct explanation of A. And A is true but R is false. So according to you, beta, out of these 4 options, which one is correct? According to you, which one is most likely to be correct? Yeah, ketos give Sullivan's test faster than aldose. Is it true? Yes, right. So absolutely that is A is true and the reason is false. That is Sullivan's test is a differentiating test for the ketos and aldose. Just remember this point, beta. This test is a differentiating test between ketos and aldose, right? And this test relies on the principle that ketohexose are more rapidly dehydrated to form 5-hydroxymethyl furfural when heated in the acidic medium, which on condensation with rescurinol, cherry red or brown red color complex is formed. And this indicates the positive test. So we can say that, yes, ketos give Selwyn's test faster than aldose, right? So this is the correct answer for this question. That is option number 3. That is assertion is true, but the reason behind this assertion is very much false, right? Okay. Now, let's move to the next question. That is the question asks a short peptide on complete hydrolysis, right? A short peptide on complete hydrolysis produce 3 moles of glycine. So what produce beta? It produce 3 mole of glycine. So 3 mole of right? 3 mole of glycine, 2 mole of leucine. Okay, so 2 mole of leucine, right? And 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 2 moles of valine and 2 moles of valine as well, right? 2 moles of valine per mole of the peptide. Now the number of peptide linkage in it are, you have to calculate the number of peptide linkage. You observe that now many questions were coming from this topic alone, that is from peptide bond, right? So this is very important topic, and please try to understand this topic in a good way so that you are able to solve question related to this topic only, right? Okay, so 2 mole of glycine is given, 3 mole of glycine is given, 2 mole of leucine and 2 mole of valine are already given in this question. Now, you have to calculate the number of peptide linkage in it. So we know that the number of peptide linkage is always equal to number of amino acid minus 1. If the amino acid is 4, then the peptide linkage is 3. If the amino acid is 2, then the peptide linkage is only 1. So peptide linkage is always equal to amino acid minus 1. Just remember this formula, beta. This is very important formula, right? So here, how many amino acids are there, beta? Yeah, that is 3 mole of glycine, 3 amino acid, 2, 5 plus 2, 7. So there here total number of amino acid is 7. So just subtract 7 minus 1. So you get to 6. So number of peptide linkage here is 6, right? So this is the number of peptide linkage in this question. I hope is it clear to you, right? Okay, so this is the number of peptide linkage. That is amino acid minus 1. That is 7 minus 1 and comes out to be 6. Now, let's move to the next question. Our question asks, a protein acts with the molecular weight of a 70,000, uh, 70,000 unit. On hydrolysis, give amino acid. One of these amino acid is, out of these four, you have to identify which amino acid is this. A protein X, protein is given with the molecular weight is also given. On hydrolysis is give amino acid. Now, one of this amino acid is out of this, which one of the amino acid is likely to be? Okay, so only in option 2, that is just observe, only in option 2, alpha amino acid is given, right? Because in all these, there is no alpha amino acid, and we know that protein is made up of only alpha amino acid, right? So protein is made up of alpha amino acid. So out of this 4 option, it is very interesting, and very tricky type of question, because many of the students get confusing that how we identify, because we have a protein, we know that protein having a large structure and having this much of weight, then how can you predict that from which amino acid it made up of, right? So there is a small trick behind this question, and what the trick is, beta, you have to identify the alpha amino acid, right? Only alpha amino acids are used for making protein. Any protein is made up of alpha amino acids only, right? So out of these 4 options, just observe option number 2 very carefully. So you can observe here is the functional group. This carbon is known as alpha carbon, right? So alpha amino acid is present here. So out of these 4, only option 2 is correct, right? I hope is it clear to everyone? Having no doubt? No. Shall we move? Okay. So only in option 2, alpha amino acid is there. Okay. Now, the next question is a match list 1, which list 2 type of question. So in that list 1, we have given some name of the test. In list 2, we have the functional group or a class of compound are given, right? So in A, the given is Mollis test. In B, it is given as Burette test, carbalamine test, and Skiff test. You have to identify the functional group or the class of compound. So out of these 4, now third one is very easy. Third one is very much easy, and you understand why it so easy and how will you remember this, right? So the carbalamine test, as you know, that is carbalamine test is basically used for what? Carbalamine test is basically used for detecting the primary amine, right? So carbalamine test is for primary amine and C is equivalent to 3. So out of this, which having 3, C is equal to 3, beta, that is option 1 and option 3. So just neglect option number 2 and option number 4, right? So just neglect this option number 2 and option number 4. Okay. So option number 2, option number 4 is neglected. Out of 2 options, that is option number 1 and option number 3. You have to identify which one is correct one. Now, next move to the next question, the skiff test. Skiff test is basically used for what? Skiff test is basically used for what? Yeah. And it is used for the, peptide, aldehyde, or carbohydrate, right? Okay. So let's see the solution behind this. We know that the carbalamine test is used for the primary amine, right? Similar skiff test is used for the aldehyde, and the Burette test is used for peptide, and Mollis test is used for carbohydrate, right? So this test is used for carbohydrate. Okay. So these are the basically the test basically used for this following functional group, right? So this is how you can remember this. So this is the correct, correct match of list one with list two. So just try to learn this, because this is one of the important thing. And this type of question basically, if you learn this thing only, then you can only get to know that is for which test is used, and for which compound or functional group which test we are going to use, right? So just try to learn this. Okay. Now, next move to the next question, right? That is match list one with list two. List one, that is the name of the polymer, and list two is the uses. So if I'm talking about the glyptal, okay, so this one is one of the glyptal, and the second one is the neoprene and the asprylene and low density polythene, right? So this question is basically from polymer, right? So this question is from polymer chapter, please. Here now I'm going to discuss some question of polymer only, right? And let's start with the question. That is, the first one is a glyptal, neoprene, acryline, and low density polythene. And you have to match this with the their uses, right? That is whether they use in a flexible pipe, synthetic wool, paints and liquor and gaskets. So let's see the solution behind this. That is the second one, right? Second one means what, beta? Glyptal is used as a paints and liqueurs, right? Glyptal is used as a paints and liqueurs. Similar, and the neoprene. Neoprene is used as a gasket. So the correct option is B. So neoprene is used as a gasket. Similar, aniline is used as synthetic wool. So this is synthetic wool. And the low density polythene are used in flexible pipe, right? So this is for D. So this is the correct answer for this question, right? Correct match type of question. Now again, one match type of question is there basically in polymer. Now what happened? They give question in this type of only, like match the sometimes they are given the type polymers types and their classification related to the polymer with their properties, and you have to match, that is in which they have a feeling a strong force and in weak force are there, which show elasticity, which does not show elasticity. Or we many time questions are coming like the uses of polymer, like Teflon is used for what, and nylon 66 used for what. So such type of questions are generally given in the polymer, right? So you get to know the idea what kind of question generally asked in this chapter. Okay, so let's do the next question. That is again list one with list two matching type of question. So what the option he asked, beta? Elastomeric polymer, fiber polymer, thermosetting polymer, and thermoplastic polymer. So they are basically the properties, and you have to match them with the list two. We all know that the if maybe it happened next time the question are coming this type of only and related to their force. For example, if someone asks in list one the same component is given, and list two they are asking forces, so this question can be of two type, right? Maybe here forces are also given, like in which elastomers, fibrous, thermosetting or thermoplastic, in which they having a high force of attraction, in which they having a low force of attraction. Which one can never, it means if they broken, they cannot be regain its shape originally. So this type of question can also be coming, right? Now let's see the solution. We know that the neoprene is a elastomers, right? So neoprene is a elastomers. Polyester means fiber. Polystyrene means thermoplastic, right? Polystyrene means thermoplastic. And what is urea formaldehyde reason? It means it is a thermosetting polymer, right? So this is a thermosetting polymer. Thermosetting polymer, right? Okay, so these are the neoprene and polyester, polystyrene, urea formaldehyde. These all are the the category of this. Now the next question is caprolactam when heated at a high temperature in presence of water. Okay, when the caprolactam when heated at high temperature in presence of water, it gives what? Teflon, Dacron, nylon 66 or nylon 6. So we know very well that caprolactam is used in the preparation of nylon 6. When we heat caprolactam, at a high temperature, then the formation of nylon 6 takes place. So this question can also be asked as what is the monomer used in nylon 6,6? So caprolactam, right? So caprolactam, this word you must remember this. Caprolactam is used in the manufacturing of nylon 6. So here, so this is the structure of caprolactam, and when you heat caprolactam in presence of high temperature, then the formation of nylon 6 takes place, right? So this is the correct answer for this question. Now, again move to the biomolecules. So this question is from biomolecules, right? So what the question asks, beta, a polysaccharide acts on boiling with dilute H2SO4 at 393 Kelvin under 2 to 3 atm pressure, give Y. Okay, so a polysaccharide acts on boiling with dilute H2SO4 at 393 Kelvin under 2 to 3 atm pressure, give Y. Y on treatment with bromine water give gluconic acid, right? Now, X contain beta glycosidic linkage only. The compound X is. You have to identify the compound X. What the compound X is, right? Starch, cellulose, amylose, yeah, amylopectin. So the in the first line you observe that it is a polysaccharides, right? And the polysaccharides acts on boiling with dilute H2SO4. It undergo at 293 and 2 to 3 atm pressure, give Y. And Y on treatment with bromine water give gluconic acid. So we know that when we treat, Y with the bromine water. So bromine water test is given by which gluconic acid. We know that glucose given a structure. Okay, glucose will show the structure of glucose when treated with Br2, it will give gluconic acid, right? Now X contains beta glycosidic linkage only. The compound X is. You have to identify the compound X. Yes. So compound B is cellulose containing beta glycosidic linkage only. So only cellulose out of these four options, only cellulose containing beta glycosidic linkage. So just remember this. Only cellulose out of this four containing beta glycosidic linkage, not starch, amylose, and amylopectin. Right? I hope is it clear to you? Okay. Now, in Ella, Nile, Glycine, and the number of peptide linkages. So we know that this is the name of the amino acids are given. So just observe the 3-letter words. Okay, and out of these 3 letter, you can easily calculate the number of peptide linkages. So there are 5 amino acids. So we can know the formula now. The number of peptide linkages beta always equal to n minus 1, where n is the number of amino acid. So it comes out to be 5 minus 1, that is 4. So number of peptide linkage is 4, right? How will you say that beta there will be 5, right? Okay. So total number of the one is alanine, next is glycine 2, leucine 3, alanine 4, and this is valine. Okay, this is 5. So total number. Yeah, that is a total number 1, 2, 3, 4, and 5. So Ella, this one. Right. So total number of amino acid here is beta. How much? That is 5. So we know that the number of peptide linkage is always 5 minus 1. That is 5 minus 1 is equal to 4. So total number of amine peptide linkage here is 4. Now, match list 1, which list 2, right? Match list 1, which list 2. You have to match the list 1 with list 2. And list in list 1, the enzymes, and list 2 conversions are given, right? So you have to identify this, out of this which one is correct and which one is not correct, right? So choose the most appropriate answer from the following. First, in enzyme, some name of the enzymes are given like invertase, gymase, diastase, and maltase. And the conversion in the list 2, there is given starch into maltose, and which will convert maltose into glucose, which will convert glucose into ethanol, and which will convert cane sugar into glucose, right? So out of these 3, you have to choose the correct one. So we know that invertase basically used for the cane sugar, and will convert cane sugar, glucose and fructose. Okay, so invertase is used. Invertase is used to can convert sugar into glucose, right? So it will convert sugar into, yeah. So it will convert this, right? And the next one is, next what we use beta? Next is zymase. So zymase is used for the conversion of glucose to ethanol and CO2. Similar, diastase is used for the conversion of starch into maltose. And maltase enzyme are used for the conversion of maltose into glucose. Okay, so just remember this. This is very important, you know. This is very important name of the enzyme. You must be remember because several times the questions were coming from this topic, that is which enzyme is used for the conversion of which into which, right? So invertase is generally used for converting cane sugar into glucose and fructose, and gymase is used for the converting glucose into ethanol and CO2. Just remember this, glucose into ethanol and CO2. And diastase is used for the conversion of starch into maltose, and the maltase enzyme are used for the conversion of maltose into glucose. So just remember this, right? Okay. Now, next move to the next question, and this one is very important, and it's a very simple question as well, because many of you know the answer of this question, right? Which one of the following is a water soluble? So we know that only vitamin B and vitamin C, that is vitamin B and C, are water soluble. Water soluble vitamin. That's why they are needed in our diet, right? Because they are water soluble. Now, the other vitamin, that is A, vitamin D, vitamin E, vitamin K, they all are water insoluble vitamin. That is a fat soluble vitamin, right? They are the fat soluble. So just remember this, B and C are the water soluble vitamin, and A, D, E, K are the fat soluble vitamin. Now in this question they are asking that is not excreted easily, right? So which of the following is the water? Because we know that if the vitamins are water soluble, then it can be excreted easily out from our body, right? So that's why they need to be taken. Now in this question they are asking which of the following is a water soluble vitamin and that is not excreted easily, जो जल्दी से बाहर नहीं निकलता. So out of these three, vitamin B12, right? Vitamins B12 is the water soluble vitamin that is not excreted easily. So the correct option for this question is vitamin B12. Now, again, this question is statement and statement two type of question. This statement one state that maltose has a 2 alpha D glucose unit, right? Maltose has a 2 alpha D glucose unit linked at C1 and C4 and act as a reducing sugar. So maltose has 2 alpha D glucose unit, right? Linked at C1 and C4 and act as a reducing sugar. Statement two state that maltose has a 2 monosaccharides alpha D glucose and beta D-glucose linked at C1 and C6, and it is a non-reducing sugar. So beta, out of these two statements, which statement is true? Whether the both statement is true, or we say one statement is true and another is false. So which one is the correct option for this beta? So let's see the structure of the glycoside. This linkage is known as beta glycosidic linkage, right? This is known as glycosidic linkage. Glycosidic linkage. So here we observe now, how well can we say whether the this is reducing or non-reducing? We can say that on the basis of only, right, whether they have a free group or not. So here we can observe that this aldehyde group is free, right? This group is absolutely free. So this one is reducing with respect to this one, and this is there is a glycosidic linkage between 1 and 4 also. So statement one is absolutely correct, right? Statement one is absolutely correct. That is maltose has a 2 alpha D glucose unit linked at C1 and C4 and is reducing sugar. Why this is recording sugar? Because it's having free aldehyde group, right? So it having free. Just like in this O is attached to this carbon, so this is not free, but this O is absolutely free, right? So in this the glycosidic linkage between 1 and 4 takes place. So this is absolutely correct. So option, statement one is correct, but statement two is false, right? So the correct option for this question is C. That is option C. Option C is the correct answer for this question. I hope is it clear to you? Yeah. This structure, this represents the glycosidic linkage, and this is a Howard projection, right? Okay. Now the next question asks stability of alpha helix structure of proteins depends upon. Okay. So they are asking a stability of alpha helix structure of proteins depends upon what, right? Whether it depends upon the dipolar interaction, hydrogen bonding interaction, van der Waals forces, pi stacking interaction. So out of this four, you have to choose the right one, right? That is the stability of alpha helix structure of protein depends upon, right? Dipolar interaction, H bonding interaction, van der Waals forces, or pi stacking interaction. So you know that alpha helix. So when we study the structure of protein, we get to know that the primary what's the primary structure of protein represent, beta? The primary structure of protein represents the sequence of amino acid, right? Sequence of amino acid. Sequence of amino acid, where the secondary structure represent in there are the two types, that is alpha helix, right? So in this only alpha helix and beta pleated seed. Pleated seed. So secondary structure further classified into two types, that is alpha helix and beta pleated seed, right? So this is from secondary structure. Now they are asking what is the stability of the alpha helix structure? It is due to dipolar interaction, hydrogen bonding, or van der Waals. Yes, so it is very simple. That is hydrogen bonding. That is mostly hydrogen bonding is responsible for the stability of alpha helix form, right? So the correct answer for this question is option number B, that is a hydrogen bonding. So only hydrogen bonding mostly responsible for the stability of a alpha helix. Now, the next question is, this is also a very important question, that is what happened when the sugar is boiled with dilute H2SO4, right? So when the sugar X is boiled with dilute H2SO4 in alcoholic solution, two isomers A and B are formed. A on oxidation with HNO3 give saccharic acid, whereas B is a laboratory. The compound X is, you have to identify the compound X. Which compound X is this? Which compound is likely to be this, right? So let's read the statement first, right? When sugar X is boiled with dilute H2SO4. So some sugar is there. When they are boiled with dilute H2SO4 in alcoholic solution, they give two isomers A and B. A on oxidation with HNO3 gives saccharic acid, whereas B is a levorotatory, right? So you have to identify the structure. We know that here X is what? That is C12S22O11, that is a cane sugar. Cane sugar on hydrolysis, it will give D-glucose and D-fructose, right? And this is alpha 52.7 degree, muta rotation values are given. Alpha is equal to minus 92.2 degree. When this is treated with HNO3, the formation of saccharic acid also takes place. So which of the following is, this is the two isomer beta A and B. And they are the levorotatory as compared to this, right? Opposite to this. So the correct option for this question is what? B, that is sucrose, right? So sucrose is the correct answer for this question. Now, we already, few questions back, we know that Gymes and Gymes used for the conversion of what into what, right? So in this question, they are asking when the C6H12O6, that is glucose, right? So this is the glucose, nothing but glucose. So they are asking when the glucose is treated with an enzyme, gymase, A is formed. Now when this A is treated with NaOI, then the B plus iodoform is formed. The number of carbon atom present in the product B is. You have to identify the number of carbon product present in B. So this is important and very interesting question. Yeah, let's see the solution behind this. So we know that when the C6H12O6 undergo gymase, it will form the formation of carbon dioxide plus alcohol takes place. We already know, right? As we know now, just yeah, in this only we know that gymase enzyme is used for the conversion of glucose. That is, it will convert glucose into ethanol and CO. Okay, so from here we know that. Okay, so when we treat glucose with the gymase, right, then the formation of what takes place, beta? That is alcohol plus CO2. So this is alcohol, right? Alcohol plus CO2. Now, when this alcohol is treated with NaOI, then the formation of this takes place, that is SCO and a formic acid, right? This is known as what? Sodium salt of formic acid. So this is no. Now you have to calculate the number of carbon atom present in B. So in B, how many number of carbon atom are present, beta? Only one, right? Only one. So the correct answer, that is number of carbon atom present in B is one only. Just try to know is because when this treated with imine A, then the formation of what takes place beta alcohol. Now when this alcohol is treated with NaOI, na, then formation of formic salt of sodium salt of formic acid will produce. Right. Okay, so this is all about the this question. That is in this question they are basically asking the number of carbon atom present in B. So here we can easily observe that the number of carbon atom present in B is one only. So one is the correct answer. Now, the next question, the structure of protein that is unaffected by heating is, okay. So you have to identify the structure of protein that is unaffected by heating. Okay. So whether it is a secondary structure, tertiary structure, primary structure, quaternary structure, right? So you have to identify the structure of protein that is unaffected by the heating, which having no effect on heating. So we know that that is something called denaturation of protein as well. Whenever there is a change in a temperature of the body or change in the pH of the body, then the secondary, tertiary, quaternary, they all structure may be changed except primary. Primary structure never be changed. Why? Because primary structure, what represent? They represent the sequence. So if the primary structure is destroyed now, then amino acid also, they become different amino acid and a different kind of proteins we get, right? So the primary structure never get destroyed. So, except primary structure, all structure, that is whether it is a secondary, tertiary, quaternary, they all get destroyed, but the primary structure never get destroyed. So, the correct answer for this question is that is the structure of protein that is unaffected by heating is primary structure, right? So, is it clear to all? That is the primary structure of protein is unaffected by the physical or a chemical change because it represents the sequence. If the sequence is like A, B, C, again A, B, C. So if this sequence is destroyed, if this will become A, B, A, B, A, B, then this is known as some another protein, right? So this is not the same protein as ABC. So if the sequence of the amino acid get disturbed, then it converted into another protein, and it lose it, and it loses its their native protein structure, right? So that's why primary structure is this question can also be asked as denaturation of protein. What happened to the in denaturation of protein? What happened to the primary structure? So it is a very similar question like this because in this also the primary structure get never destroyed. So primary structure always remains constant. Okay, there is no change in the primary structure upon any physical or a chemical change, like change in the temperature of the body or change in the pH of the body. Right? Okay. Now, next move to the next question, that is which of the following is an example of polyester? Okay, so you have to identify which of the following out of these four now, which of the following is an example of polyester, right? So whether it is a butadiene styrene copolymer, melamine polymer, neoprene, या poly beta hydroxybutyrate co beta hydroxyvalutrate, right? This one is a very important type of polymer. Just try to learn the name, right? Because they are PHBV, PHBV. So they basically known from this name only. That is PHBV. So someone maybe ask you what is the full form of PHBV. So it is full form of the PHBV is poly beta hydroxybutyrate co beta hydroxyvalerate. So out of these four options, now which of the following is an example of polyester? Right. So polyester, you have to identify the example of polyester. That is nothing but PHBV. So polybeta hydroxybutyrate co-beta hydroxyvalerate, that is PHBV, belong to the class of polyester, right? So they belong to the class of polyester polymer. Okay. So I hope there is no problem in this. Okay. Now, which of the following is not an example of condensation polymer? So what is condensation polymer, beta? So condensation polymer means what now? When the hexadiamine like H2N CH2, right? And this is again NH2. When this treated with, okay, when this treated with adiapic acid, right? That is CH24 and this is COH, right? When this treated with then the small removal of H2O takes place, right? Then the removal of H2O takes place. So these type of here I am taking, ethylene, hexadiamine and adipic acid. These two are the monomer of nylon 66, right? So these two are the monomer of nylon 66, in which there is a removal of a small molecule of water and molecule of water, right? And the formation of nylon 66 polymer takes place. So in this question, they are asking which of the following is not an example of condensation polymer. So nylon 6 is an example of condensation polymer. Dacron is also example of condensation polymer. So which one is better? Buta-N, whether it is a buta-N, buta-N means what? When you treat 1,3-butadiene with the acrylato, then the formation of buta-N is formed. So the correct option for this question is butan, because butan is the addition copolymer of 1,3-butadiene and acrylonitrile. Right here we can say now this is 1, 2, 3, and 4. So this is 1, 4, 1, 3, right? This is 1,3-butadiene and this is called acrylonitrile, CH2CHCN. On the similar basis, one another is there like Bunas. So try to remember this as well. That is Bunas. Also try to learn Bunas as well. In this also, the same monomer like CH2 double bond, CH, CH double bond, and CH2. Okay, so this is buta 1,2,3 diene, and this is treated with styrene. So what is the styrene beta? Styrene means nothing but CH double bond CH2. Right. So in this, by doing this polymerization, the formation of what takes place beta? The formation of Buna astex is like this. That is, it will become CH3 CH double bond CH CH2. Again this will become CH3 CH2. This will become CH, right, and this is CH3. So this is known as Buna S. Right. So Buna N and Buna S. Just remember one important note here. In Buna N, we use acrylonitrile, where in Buna S, we use styrene. Right. So this is all about. So Buna N is an addition copolymer. So the correct option for this question is beta Buna N, because in this question they are asking which of the following is not an example of condensation polymer. So this is absolutely correct. That is Buna N is not an example of condensation polymer because it is an example of addition polymer. Now let's move to the next question. That is the Novolec polymer. This one is very, very important, right? Novolec is a monomer. Novolec is a, we can say, we can't say it is a monomer, or rather we can say it is the intermediate product of bakelite. Okay. When you prepare bakelite, then the intermediate product Novolec is formed. The Novolec polymer has a mass of 963 gram. The number of monomer unit present in it. So you have to calculate the number of monomer unit because their molecular, because their mass is given. So Novolec polymer has a mass of 963 gram, and you have to calculate the number of monomer unit present in it. So we know that the monomer unit of Novolec having this structure and having molecular mass of 124 AMU. So it's having molecular mass of what beta? 124 AMU. Now, upon considering molecular weight of a polymer as a 963 AMU, that is the question already given, right? Now, if you during the formation of Novolec, n minus 1 Newton of water are removed, right? How many water are removed, beta? That is n minus 1 unit of water is removed. So the answer is, correct answer is, that is n into 124 is equal to 963 already given, plus 18, right? Plus 18 into n minus 1. Okay. So from here you will get n. So what n comes out to be beta? 9. So 9 is the correct option, right? So just remember this formula. Whenever the molecular mass something you want to calculate, now just use the formula. That is n into my molecular mass of the monomer unit is equal to 963 already given, plus 18 into n minus 1. That is 80. Why we use 18? Because the molar mass of water. This is the molar mass of water. And what is n minus 1 beta? Here the n minus 1 unit of water are removed here. Right. So the correct answer for by solving will get n is equal to 9. Right. I hope is it clear to everyone? Okay. Now, Which of the following sets are correct? Copolymer, Buna S. Whether it is a copolymer, what is a homopolymer and copolymer, beta? Homopolymer means when they are composed of the same type of monomer, and copolymer means when they have a two different types of polymer. So which of the following is the correct? So copolymer, Buna S. So Buna S having two different types of monomer. Condensation polymer, in which there is the removal of small water molecules. So nylon 66 is a condensation. Fiber is equal to nylon 66. Thermosetting polymer is like terline, and homopolymer is like Buna. Homopolymer is Buna. No, it's not correct. Where the copolymer like Buna, yeah, it is a correct one. Condensation. So A and B are correct. Now C, D, and E. Out of these three, which one is correct, beta? Yeah, let's see the solution. That is, we know that which of the following sets are correct, right? So Buna S is a copolymer. This is Buna. Buna S. Buna S is a copolymer of butadiene and styrene. This is absolutely correct. Nylon 6 is a condensation polymer of adiapic acid and hexadiamine. This is correct. Nylon 66 is a fiber. Okay? So this one is also correct. Now terline is a fiber, not thermosetting polymer. Right? Terline is a fiber, not the thermosetting. This statement is wrong. And Buna is a copolymer, not homopolymer. Right? So which statement is true, beta? That is A, B, and C. So these three statements, that is A, B, and C. These three statements are correct. Above three statement from the top, that is A, B, C, are correct. And last one, that is D and E, are absolutely wrong statement. I hope is it clear to you? Yeah. So this one is very important. Try to learn this term. That is what is mean by copolymer, homopolymer, and the condensation or addition polymer. So that's this four name. The first one is homopolymer. What is this mean by beta homopolymer? Homopolymer means what? They compose of same type of monomers, right? Same type of monomers. So when they have a same type of monomers, then it is known as homopolymer, right? Similar, when they having different types of polymer like copolymer. So what is copolymer, beta? When they have a different types of monomer. Different type of monomers, right? So homopolymer means same type and copolymer means different type of monomer. On a similar basis, the third one is condensation polymer. What is this condensation polymer, beta? Condensation polymer means there is a removal of water molecule. Yeah, there is a removal of water molecule. And on the same base, if I'm talking about the addition polymer, in addition polymer, there is no removal. No removal of water molecule. So please try to learn this all four, because maybe questions are coming and they are asking related to this, that which will belong to the homopolymer, copolymer, or anything. Right. Now, this question is also very important. This is also match type of questions, because you observe many questions in polymers are only match list with list two type of questions, right? So in this, the bakelite, basically in this, the name and what the use of this glyptal, PVC, polystyrene, and bakelite. So basically they are used in which purpose bakelite is used, whether it is used in electrical switches, paints, liquors, or water pipe. PVC. We know that the PVC pipe are used in water. Okay. So the correct option for C is 4. So C is equivalent to 4. So only in option A, this is true. Option B, C, D, nothing. Right. In C third, C2, and C1. So it's very simple to guess, right? PVC is used in a water pipe. Now, on the similar basis, A, that is bakelite. Bakelite used in electrical switches. So electrical switches are made up of bakelite. Similar, the PVC D, that is polystyrene, is used in radio and television cabinets, right? Polystyrene is used in radio and television units. Okay, and on the same basis, glyptal is used in paints and liquors, right? So they're basically used in paint. So this one is also very important. Bakelite is used for the electrical switches, for big electrical switches. Glyptal is used for making paints, PVC is used in water pipes, and the polystyrene used in radio and television cables. So the correct option is D, right? And the more information about the bakelite, na, just remember this in extra information as well. Bakelite, it is a thermosetting polymer used for making electrical switches. Glyptal manufacturing for the paints and liquids. PVC used for the manufacturing of water pipes, raincoats, and handbags. And polystyrene used for the manufacturing of radio and television cables. Right? So these are the all the use of this. Now, which is true about the Buna. So it is a linear polymer of 1,3-butadiene. It is obtained by the co-polymerization of butadiene and styrene. This is wrong because by this we get Bunas only. It is obtained by the co-polymerization of 1,3-butadiene and acrylonitrile. Yeah, this one is absolutely true, right? So it is obtained by the co-polymerization of 1,3-butadiene and acrylonitrile, right? Okay, so option C, that is the C one is absolutely correct. Now the polymer which can be stretched and retain its original structure on releasing the forces. So which type of polymer are basically? They are the thermosetting thermoplastic or fibrous. So those having the elasticity of nature, elasticity. So Buna N is a synthetic rubber which can be stretched and regain its original status on releasing the forces. Right. So they show the elastic property. So Buna N is the correct synthetic rubber which can be stretched and retain its original status on releasing the force. Okay. So I hope is it clear to everyone? So we did many questions related to this two chapters, that is biomolecules and polymer. And these type of questions generally coming in your examination. It is include all your 3-4 years PYQ questions, and this type of questions only they are going to be asked in your examination. So prepare well and try to read this question, try to solve more question as you can, and by doing this you can understand the type of question they are really asking. So I tried my best to explain you the most important question that are coming in your examination and maybe coming in your future examination as well, right? So just try to solve this question, and you can easily solve a question related to this chapter, right? So let's meet on the next chapter and with the some new topics and all, right? So till take care and just read it out. Okay, take care.